called the tropical pack, which, I don't know, that's not tropical and that's not tropical to me. But that one, okay, that's a little bit more. I don't see it with those. Count the number of suns, count the number of hearts, write down the total of each underneath. You have this on paper right in front of you. That's why I give you a copy. Count the number of suns, count the number of hearts. Write the number underneath. Just under here somewhere. Just write down how many suns, how many hearts. Bless you. How many sons?
You have 2 sons?
I have 2 daughters because my dogs are girls. How many hearts? 3. Agree, 2 sons, 3 hearts? Well, remember I told you mathematicians, we don't like words because they scare us? We like symbols and we like notation. So I would never write this as 2 sons because I don't like the words. I would write this as 2 S. S meaning? What would I write instead of 3 hearts? That's where variables come from. It's just an abbreviation. So usually we use X just because we don't want to write out what the word is. That's all it is. It's just something. It just represents an object. And when we don't know how many, that's what it represents. This is adding and subtracting polynomials, just like we did adding and subtracting fractions. But we call it other things at times. Sometimes we call it simplifying. And sometimes we call it collecting like terms. Those all are going to mean the exact same thing, whether it's adding and subtracting, simplifying, collecting like terms, all mean exactly what we're going to do today. Algebra is going to come back in every single grade, and if you go on to university and you take any kind of math course, it's never going to go away. Algebra is the foundation of mathematics because what we're trying to do is find stuff out. Collecting like terms is going to come back in every single algebra unit, every single course you're going to take. Friday with grade 12s, guess what the last step of their question was? Collect the like terms. Today I'm going to teach them in grade 11. Guess what the last step is going to be? Collect the like terms. So if you don't understand this unit, you need to fix it sooner rather than later because this is going to come back over and over and over. It sounds scary, collecting like terms. It sounds like you need to go out and collect something. All it is counting. It's like counting up the number of algebra tiles you have in front of you. How many x squareds do you have? You had 6. That's all we're doing today is counting. Like terms have to have the same, go back to your vocabulary words in your head, same variable, and exponent. Coefficients can be different. It's just like me telling you the like algebra tiles have to have the same shape and color. So they have to be big squares and they have to be whatever color you made them, or they have to be bars, or they have to be little squares. Same idea. We're going to do this 2 ways. We're going to do it with the algebra tiles first. And I'm not going to lie, if you get this, the algebra tiles are going to be frustrating because it's going to take you longer. Just go with it. Eventually we're going to let go of the algebra tiles and we're just going to do it using algebra. Simplify using algebra tiles. 3x plus 2 minus 5x minus 7. I want you to put those 4 terms of algebra tiles out in front of you. So start with 3x. Show me that out in front of you, 3x. Using your algebra tiles. Nope. What should you now have out in front of you? 3 bars. Then I want you to put out plus 2. So right beside it, show me plus 2 on your desk. Eric, with your algebra tiles for the 4th time. How do you show me plus 2? 2 little squares. Then beside that, put negative 5x. Whoa, negatives, what? Yeah, it's just the white side. What should you have out in front of you? 5 white bars. And then beside that, negative 7. So you should have 4 little piles in front of you that represent the 4 terms. Show me negative 7. Oh, Kayla, you were tactile. And I'm not auditory. I'm like, it's squeaking. It's all I can look at. How do you show me negative 7? 7 white boxes. Now, when the question says using algae tiles, it doesn't physically mean you need to use them. If you can just draw them, that's okay. If you need to physically put them out because you're tactile, then do that. But if your brain can jump right to the drawing, jump right to the drawing. So we're going to draw what you have in front of you. So the first is 3x, which should be 3 colored bars. Here's how I do colored, because I don't want to have to take the time to color them in completely. So as long as you do something like that, it shows me that you understand it's the colored side. Then the 2 would be 2 little squares, again, colored in. The negative 5 would be 5 white bars. And the negative 7 would be 7 little squares that are white. Okay, so you have a choice. When the question says with algae tiles or using algae tiles, you don't physically need to get them out if you can just draw them. If you want to get them out and play, there's nothing wrong with that. Now all we're going to do is count up, but the trick with algae tiles is you get to cancel them first, and this is my favorite part of algae tiles. What do you know if I have a colored bar and a white bar? They equal 0, so I'm going to cross off 1 white bar and 1 colored bar. What do you know about my second colored bar and white bar? They're also going to cancel, so I'm going to cross 1 and 1. Then I'm going to cross the third bar with the third colored. Can I cross off any more white bars? Why not? Because there's no more colored. Then I'm going to do the same things with the little squares. 1 colored with 1 white. 1 colored with 1 white. It sounds so racist, but it's not. Can I cross off any more of the little squares? How do I know? Because there's no more colored squares remaining. And then I'm just going to look at what do I have left. Well, I have 2 white bars. What does that represent?
2x.
Why is it negative? Because they're white. And how many little squares do I have left? Negative 5. That's simplifying or collecting like terms or adding and subtracting polynomials using algae tiles. It's physically just counting. How do you know when you're done? How do you know when an expression is simplified? Kind of. There's no something. And what do we call the boxes of different colors? No like terms remain. So it means there's nothing else we can cancel.
Sorry, but if you have like a big box and you're like a bunch, like colored big box, there's a bunch of little white ones, so you'd be able to cancel.
Nope, don't work that way. Take a look at this. For a lot of brains, when they first see this, this is a lot going on. There's x's everywhere. There's exponents everywhere. There's brackets. Visually, this can be really, really overwhelming. This is just counting. That's all this is. So this time we're going to do it just by drawing and canceling rather than just putting the tiles out. I'm just going to go in order. How do I draw 1x squared? And is it colored or is it white? How do we know? Then the next in the line is plus x. How do I show plus x? And how do I show plus 3? Just keep going down the line. 2x squared. How do I show 2x squareds? Ooh, that went wonky. I don't care. You can still see it's a big rectangle, or square in that case. Negative 5x. And negative 4 will be 4 little white squares. Again, if you get this, the algae tiles will be annoying because it takes more time to draw. Just go with it. You can just ooh and ah my pretty new colors. Humor me. Favorite part is crossing stuff out. Can I cross out this big square with this big square? Why not? They're both positive. So the only thing I can cancel is a white with a colored. So is there any of the big squares I can cancel? What about this one bar? What can I cancel it with? What about the three little colored squares? So 3 can go with 3. Now I'm just counting what's left. How many big squares? So I have 3x squareds. How many bars do I have? They're white, so it's going to be negative 4x. How many little squareds do I have? Questions so far? We're just counting. That's all it is. It looks scary because of all the x's and brackets. Just counting. What about subtraction? A synonym for subtraction is, what does a synonym mean? Kind of. That's an antonym. Synonym means same word for subtraction, and it's funny because the word is actually opposite. If you subtract something, you're taking the opposite value. So what's the opposite of 2? Negative 2, because that's subtract 2. And what's the opposite of 7? Negative 7. What's the opposite of negative 3? Positive 3. So another word for subtract is just opposite. So what I'm going to do is I'm going to put out in front of me 3x plus 2. Start with that. So lay out in front of yourself 3x plus 2. Like actually lay it out with the tiles. Like actually show me the tiles. Show me the tiles. What did you have out in front of you? 3 bars that are colored and 2 colored squares. I'm going to ignore that negative for a second, and I want you to put out beside that x plus 2. So beside your 3 bars and 2 little squares, I want you to put out x plus 2. What should you have in front of you for the x plus 2? 1 colored bar and 2 colored little squares. The only thing that's different when there's a subtraction in front of the second polynomial is we flip over the second polynomial. So take your x plus 2 and flip it over. The only thing that's different with subtraction is we flip it over. How do you show me that? Well, I'm going to draw the 3x plus 2 just like we always did. I'm going to draw my x plus 2 before I did anything to it. Now, if this is adding, we would do nothing. Because this is a subtraction, all I'm going to do is take these guys and flip them over. So now I would have a white bar and 2 little squares. Now I'm going to count them up. Can I cancel anything?
Yeah.
The white bar with colored bar. 2 white squares with 2 colored squares. What do I have left?
2x.
That's subtraction. Show me your thumb so far. I'm getting these tiles, not getting the tiles. Now I'm going to ask a different question. Do you like using the tiles? Show me I like the tiles, I don't care, I hate the tiles. Okay, that's what I need to know. This one we're just going to do by drawing. So I'm going to draw the first one exactly what I see. Draw me an x squared. Draw me an x. And draw me 3. Now for the second one, rather than drawing it twice, all I need to do is look at this negative and know that I'm going to draw the opposite of what I see in that second bracket. So instead of 2x squared, I'm going to draw negative 2x squared. Ooh, that's more of a rectangle than a square. We'll just go with it. Instead of drawing negative 5x, I'm going to draw positive 5x, so the opposite of negative 5x. Instead of drawing negative 4, I'm going to draw the opposite, which would be positive 4. Now we cancel and we count. What can I cancel?
X squared with negative x squared.
Okay. What else? Oh, that's really disappointing. I really like crossing stuff out. Okay, count. How many x squareds do we have? Why didn't I write the 1? We don't need to. We know if there's no coefficient, it's assumed to be 1.
Wouldn't you go in order though? From left to right?
We always go x squareds, then x's, then numbers. Good question. How many x's do we have? How many little guys do we have? Questions so far? I heard somebody say 9, so I wrote it down. Questions? Put your algebra tiles very carefully back in the envelope because we will use them later on the unit, so don't lose those little, especially the little guys. Could you yawn louder? I didn't see the back of your teeth there. That's not a goal if it hits the edge.
The edge doesn't count it.
Now we're going to do it without the tiles. Again, we're still doing a counting process. What makes a like term a like term? Perfect, just like the same shape and color in the tiles. I use different colors. If you're visual, you might want to do that with me. If you're not, don't worry about the different colors. And what I'm going to do first before I do anything is circle the like terms. I'm going to circle the 3x, and what else would be a like term? And I'm going to include that negative. Then I'm going to have a 2 with 7. Why is that a like term? Because there's no variable, so no variable makes it a like term. If you're not into the colors, you might want to circle different ways. You might want to circle one and box the other, which I'll do in the next example. And then I'm just going to add. So I'm going to put my 2 x's together. If I have 3 of something and I take away negative 5, how many do I have? And then I have 2 of something and I add 7 to it. How many do I have? 9. That's the exact same first example we did with the algebra tiles. So if your brain is like, whoa, I didn't catch that, then picture the algebra tiles. That's why you have that as a tool now. Picture 3 colored bars and 5 white bars and what's going to happen. Picture 2 and then 7 of the little squares, what's going to happen. So the algebra tiles are just a tool to help you get questions like this. M's and N's, what are we going to do? Our algebra tiles didn't have M's and N's. It's the same thing. I'm going to circle the M's first, so negative 6 of them and 8 of them. Then if I don't want to grab colors, I can circle these with a box, 4n and negative 5n. Do the m's of something first. If you have negative 6 of something and then 8 of something, how many somethings do you have? 2 somethings. And then if you have 4 of something and I take away 5 of them, how many do you have? Why didn't I put the 1? Don't need it. Getting this so far? Kind of getting this. Getting this. Good. Oh my God, there's brackets. Who cares? The only time the brackets are important is when there's a subtraction. Is there a subtraction in the middle of them?
No.
So it doesn't matter. I'm still going to circle my x squareds. I'm going to box again. If you want to change colors, change colors. And then I have my constants at the end. This is the equivalent to sorting your tiles into 3 piles. That's what we're doing by circling is sorting. And then what are we doing? We're counting. If I have 1x squared and then 2x squareds, how many x squareds do I have?
Would x and 5x be together then?
Yep. I got 1x and I got negative 5x, negative 4x. And then I have 3 minus 4, minus 1. This is called adding and subtracting polynomials, or simplifying polynomials, or collecting like terms. Those all mean the exact same thing. How do you know when you're done? How do I know this is the final answer and I don't need to simplify more? There's no more like terms. Can I add anything with this 3x squared? Can I add an x squared and an x? Well, can you combine the big square with a bar? No, same idea. X squared and x's are different. Okay, another one. Do I care about these brackets? Nope. 6x squared, 2x squareds, 5x minus 10x, minus 4 and 3. Carter, put it away, please. Add them up. Write down, don't say it, write down how many x squareds there are. Write down how many x's there are. Write down the value of the constant. How many x squareds? How many x's? What is the constant? Ooh, I heard negative 1 and 7. Questions so far? I can ask you 2 mental math questions. Don't shout out the answers. Just think about it in your head. 3 times 4. 4 times 3. Were the answers the same? 2 times 5. 5 times 2. Were the answers the same? Negative 3 times 6. Negative 3 times 6. 3 times negative 6. Were the answers the same? Okay, 3 times negative 6 is negative 18. Negative 3 times 6 is negative 18. So when you look at terms like this, the order of the variables don't matter for like terms. An AB would be the same in a pile with BAs. If you had an XY, that would be the same as a YX. The order doesn't matter when we multiply. So just make a note, and I'm grabbing my red pen because we like to do notes in red. Within a term, the order of the variables does not matter. Within a term, the order of the variables does not matter. Brody, where are your notes? Okay, but where can you get an extra copy? Okay, then write this down on paper then at the very least. What makes a like term a like term? Same variable, same exponent. Doesn't matter the order of the variables. No, so these are still like terms. I have 5 of them and then I have negative 8 of them. How many of them do I have? Now I can write that as AB, or I can write the answer as negative 3 BA. Completely your choice. Typically mathematicians put them in alphabetical order because we're order people, but there's the exact same answer whichever way you give them. Questions so far? So we have done questions without brackets. We have done adding with brackets, and now we have done combining when the variables are different. Remember, every example I give you, there's a reason, so it either has an exception or it has something different in it. And it's an example like this one that your brain is going to get you. And the question will say simplify, as they all do, and you're going to go, 1x, 1x squared, 7x, 7x cubed, 1x cubed. Can you combine when the exponents are different? No. Picture the algebra tiles for this. What would 4x squared look like? 4 big squares. What would negative 3x look like? 3 white bars. Could we combine those together? So your brain is going to think, because I say simplify, everything can be simplified. Can this one be simplified? No. What's the answer? Itself. It already is simplified. Okay, so we like to throw in a little tricky one there to see if you know when something can be simplified or not. If it can't be, it can't be. Don't try to simplify something that can't be. Okay, let's go to the subtraction. What did we do for subtraction with the algebra tiles? We flipped the second one. Did we touch the first one? No. So I'm going to recopy the first one exactly what I see. 7x squared, a minus 4x, and a plus 1. Then I'm going to take the second one, I'm going to copy it down, but what am I going to do to each of those terms? Flip it. So a 5x squared is going to become negative 5x squared. A 5x is going to become negative 5x. A negative 2 is going to become positive 2. That's the only trick with the subtraction, is you flip the sign of the second binomial or polynomial. Change the second one. Take the opposite of the second one. Now we're right back to a question like on the other side of the page. So I'm going to circle my x squareds. Let's combine them first. 7x squared, negative 5x squared. How many x squareds would I have? Picture 7 big cubes, 5 white cubes. What would I be left with? Now I'm going to do my x's. I have negative 4 and negative 5. So that would be 4 white bars, 5 white bars. How many white bars would I have? And then the last I have the constants, my 1 and my 2. Questions so far? What do we do when it's subtraction? Flip the second one. This one I'm going to keep the first one the same. 4a plus 5c minus 3c. Then I'm going to take the second one and I'm going to flip the signs. Why? Because it's a subtraction. So negative 3b becomes positive 3b. Plus c becomes minus c. Minus 4a becomes positive 4a. Collect the like terms. Let's collect the a's first. Offer of 8a. Nobody confirming. Nobody's got your back. Not one person. Very good. I have a 5c, a negative 3c, and a negative 1c. Offer of c. Where'd the 1 go? It's just there. And then I just have this lonely 3b. So what do I do when I can't combine him with anything? Questions so far? This is called adding and subtracting polynomials, or simplifying, or yes, more specific, boy. Combining like terms, high five to you, or collecting like terms. Questions so far? You're liking my new colors, come on, admit it. Aren't they pretty? A little bit. Turn and talk, find a partner, do number 13 together. Turn and talk.